Yeah. Yeah. Welcome, everybody, to another fantastic episode of Q SuperShares, powered by Q. My name is Joe Marquez, Director of Academic Innovation for Q, and we are super excited for a December edition of SuperShares for you. But before we get to that, I am super excited that we are nearing the 3-month mark for Spring Q. That is right. Spring Q is happening March 16th to 18th of 2023. That is basically about 3 months and 1 week away. I can't believe it. And it's going to be happening in beautiful Palm Springs, California. So definitely head on over to springq.org and check that out because hotels are going fast. So you want to make sure you have a place to stay when you're down there. All right. So that's enough pandering to you to come to our amazing conference. Let's get started with today's main event. I have been asked multiple times, Joe, you have a lot of great things on SuperShares, but one thing we don't see a lot of is math technology, some math apps, some math stuff. And you know what? We heard you. And that is why I'm super excited to bring on our guest for today, Rob. Rob, come on board. Here he is. Rob, welcome to the show.
Hello. Thank you.
I'm so excited that you're here, and you're coming to us from all the way across the United States in New York to bring us some amazing information about how our math teachers can incorporate more technology and insight into their daily instruction. So I would love for you to introduce yourself, maybe a little bit of your history as an educator, and then a little bit about the tool that you want to talk about today.
Sure. Thanks for having me, Joe. This is great. As you mentioned, my name is Robert Pontecorvo. I am the Assessment and Relations Lead for GeoGebra. But what's more important is that I retired in only June of 2021 as a coordinator of math for the Sewanaka Central High School District, which is my former school district. I was there for 32 years. And what's kind of different is that as a coordinator in that district, you also still teach math classes. So just like your viewers, I was a teacher in the classroom for 32 years plus. That was really how I was first exposed to GeoGebra. My school district was going one-to-one with devices. We were using iPads, and we found GeoGebra and started to basically use their apps to change the way we teach. That was the idea. It was all about changing the way we teach. Going from teacher-focused at the board to student-centered, discovery-based learning, really. And you know what, Joe? I'm going to one-up you a little bit because you said that you always have people that are looking for math content. What we find also is that we always have math teachers that are looking for high school content, right? There's often many apps out there that are for the younger grades, that type of thing. Well, GeoGebra really is K-12 and beyond, right? I mean, we find many college professors, universities using GeoGebra as well. So that's what I'm excited to show you about today. I'm excited to tell you about GeoGebra, their products, and the way it works and how it's basically out there since 2001, completely free to students and teachers and schools and kids.
And, one of the things that I absolutely love that you said is that you discovered it, right? It wasn't something that was brought to you by administrators. It wasn't an initiative the school was trying to push. It was like, we have these devices. There's got to be something to grab the attention of my students. There's got to be something that have them take hold of their own education going forward. What is out there? And you found GeoGebra. But I know the burning question everybody has right now is, what is that name about GeoGebra? How did that come to be? A little bit of history of it?
Yep, that's a great question. So GeoGebra was invented or created by Marcus Hohenwater, who is actually from Austria. And here's how the name is really a mashup of the words geometry and algebra, GeoGebra, geometry, algebra. And the idea is this. In Europe, well, let me start here. In the United States, we teach algebra in 9th grade. We teach geometry in 10th grade, maybe algebra 2 again in 11th grade. And it's not that way in Europe. In Europe, they teach algebra and geometry in 9th grade, algebra and geometry in 10th grade, and again, algebra and geometry in 11th grade, because they understand that algebra and geometry are really just two different representations of the same mathematics. So the concept behind GeoGebra is to keep the algebra and the geometry on the screen for the student at the same time. So they get both representations and they could work with both of them visually. So that's the idea behind the name GeoGebra. The other interesting thing is people say, well, you're saying GeoGebra, Joe is saying a little bit differently. There's no correct pronunciation. It's okay. You say it however you want. GeoGebra is used literally around the world. So we get all kinds of pronunciations of it, and they're all fun and they're all great.
Well, that's a great story because, I'll tell you, one of my favorite math classes going through the K-12 system here in California was a 7th grade class called Math 7 Projects. And it was different because they did exactly what you're saying. They took geometry and algebra, they melded it together and had you build based off of it, actual woodworking, actual projects. And so you learned the math, but saw a practical application for it. And I never received anything like that the rest of my education career. But what you're saying is you're using both of these mathematical applications because they're very similar. And when things are similar, they can be learned together. And that's where GeoGebra gets that name. I like that concept. And I like that strategy very much.
Yep. And, it's interesting, Joe, because you talk about that hands-on type of class that you had where you built things. I'm going to show you some things in GeoGebra you're really going to like. And GeoGebra is also software that can be used with a 3D printer. So you can literally take the GeoGebra figures that you are creating visually, digitally, and turn them into hands-on material. So it's very, very cool.
Well, that's cross-platform. That's cross-curricula. That's fantastic. That's great.
Yeah. And what it's really all about, I start with a slide that says, what? I'm showing my age with this one, but there's a band from the late 60s, started early 70s, let's say, named Rush. And in one of their songs, they have a lyric that says, changes aren't permanent, but change is. And that's what it's all about. But I often quote Henry Ford, who talks about change for the sake of change. We don't want to make change for the sake of change. We want to make change only when we know it could help us do things better. Right? That's what it's about. And I present to you this concept where, teachers often get stuck in a rut. When we work in a school, if you think about it, our schools are very similar to they were way back when Ben Franklin first invented school systems, right? And we convince ourselves that, well, we've always done it that way. We're accustomed to it. And we even fool ourselves by saying, well, the kids like it that way. And what I say to that is, really? Are you sure? Have you checked in with the kids? Are you sure they're really liking it? Because I think statistically, often we forget that many kids aren't succeeding. And even if we do have many kids that are succeeding, my theory is if we can find a way to help just one more, well, then we do that, right? That's what it's all about. It's all about just being able to help another student.
Yeah. And Rob, I want to stop you right there because that is an absolute key component to pushing education forward and innovating within the classroom, right? Getting away from what you're accustomed to because you're comfortable with it, right? And I always tell teachers, I go, there's an enemy in our classroom and it's called Titwadi. And they go, what does that mean? I go, it stands for, this is the way we've always done it, right? Yeah. That prevents us from moving forward. That creates comfortability. Mm-hmm. And when you become comfortable, you become complacent. Yeah. And things pass you by and you're missing opportunities. So I love what you said is move forward for the sake of our students because they've changed. So teachers have to change, right? The approach has to change. So I love that.
Yep. This picture is what actually did it for me. This is a real picture of two young ladies walking down the hallway in my school. I had to stop them and say, I have to take a picture of this. You'll notice they have a brand new device in one hand, right? State of the art. And in the other hand, they have calculators that haven't changed in probably 27 years. And I thought, this is bizarre. This is the way kids are walking around our school with a brand new device and a calculator that's about 27 years old or whatever it is. And it didn't make sense. And worse than that, for us, it was an equity issue because kids who can afford their own calculators had them at home. The others had to borrow our class sets in school and they didn't have them at home. So to me, I was like, you know what? This is not good, right? It's an equity issue. It's a learning issue. And really what started off as just looking for a better way to use a calculator became a better way to teach. And that's really what happened with GeoGebra. The idea is this, no longer do the acrobatic manipulation of buttons need to be getting in the way of good instruction. I'll tell you, Joe, I used to have teachers used to make worksheets. Picture 90% of the worksheet is mathematics, but then there's a column all the way off on the side where they had little pictures of buttons that they drew that the kids had to press in order to do the mathematics. And I thought, how bizarre is that we have to go through these manipulations, and teach the kids button presses and instead of just worrying about their math, right? So here's the idea, basically, when I tell people simply, GeoGebra consists of three things. This is GeoGebra in a nutshell. GeoGebra consists of one, some really beautiful dynamic calculators that you can actually use to change the way you teach. I'm going to show some of those calculators today. Second thing that GeoGebra consists of is over 1 million free resources that are community created that are out there for your users to play with tomorrow, today, right? Always free. And the third thing GeoGebra consists of is basically a way to share those resources with your class, with your kids. And that's GeoGebra in a nutshell. Beautiful calculators, free resources, and a way to share the resources with your kids.
Now, Rob, I want to ask you something really quick because, we're going to get into some demos and some cool things, and people are going to ask you, okay, but how much is this going to cost, right? There's probably some free materials, right, to get you hooked. But then when I need to hand things out to my class and actually get the analytics that I want, I'm probably going to have to fork over some money, right? So what is the extent of free when you're talking about free with GeoGebra?
That's an excellent question. And I always address that elephant in the room, particularly in the United States. People never believe it, that something is for free.
There's always a cost.
Right. GeoGebra for teachers and kids and students, researchers is completely free. Always, every part of it. There is no upsell. There is no freemium version. There is, they don't collect your data and sell your data. Quite simply, GeoGebra is, you can think of it as divided into two divisions. There's the community division, which I am part of, and there's the commercial division. And here's what that means, the commercial division. Anytime somebody else uses GeoGebra to make money, then GeoGebra gets a piece of that money. That's a commercial use, right? So let's say you have some textbook company and they put GeoGebra in their digital textbook and they sell their textbook. Well, now GeoGebra gets a piece of that money, right? Because somebody is using GeoGebra for commercial purposes to make money. Your teachers, your schools, the students, they don't make any extra money because they use GeoGebra, right? So for them, it's free. It's just every piece of it, every version of it, every aspect of it completely free as long as they are using it non-commercially. All right.
That's good to know because, finally, textbooks are useful for teachers by giving you free GeoGebra, right? That's really good to know that there's organizations out there like GeoGebra that really is looking out for classroom teachers and knowing they make their money in the global scene. So why not give it to teachers in the classroom for free? I love it.
That's it. That was the original mission of Marcus Hohenwarter back in 2001 when he actually created GeoGebra as part of a doctoral thesis. And he's just continued it since. And it's been absolutely great for the company, for schools, and like I said, for me and my school district in the past as well. Often teachers ask me this question too, Joe. What about tests? Why do I want to change my calculator if I can't use that calculator during the tests, right? Why do I want to teach with one calculator and then have my students have to test with another? Well, you can use GeoGebra on exams. Again, GeoGebra has an exam mode. It's securely locked through MDMs. Teachers can lock GeoGebra with some of their teacher management tools. And GeoGebra even has its own exam mode. So like in my old school district, not only did we use GeoGebra for classroom exams, we used it when students had special needs and went to a testing room, right, in an isolated type of situation. And we used GeoGebra for our high stakes New York State exams, right? So very secure exam mode. All right. Well, let me do this. Let me take you to the GeoGebra website. All right. I'm going to push my screen over a little bit. Okay. And I am going to open up Google or any browser really on any device. And I'm going to go to the GeoGebra website. Here on the GeoGebra website is where you can access all the calculators. However, they are all completely downloadable also as a native app. You can download them on your iPhones, on your Android phones, whatever you're using, right? So they're all completely downloadable as well. For today's purposes, I'm going to use them off the web because hopefully you and I will get to interact a little bit with these, and we need the web version in order to do that. What I think I'll do is I'll start down here with the typical graphing calculator, right? This graphing calculator emulates or does exactly what you think a traditional handheld calculator should do, right? And you'll notice this is what I was talking about, where here's the algebra view and the geometry view all at the same time. Now, keep in mind, what's different about an app also is everything is customizable. You can change the settings on anything. You can change the colors. You can change the grids. You can change the font sizes. GeoGebra is often used with students who have a visual disability. You can zoom up the font sizes, all that type of stuff. So really just completely customizable. Now, if I go back to my slides, I'm going to enter in just a normal regular equation, y equals 2x minus 1. You can see it here on the left of my screen. Y equals 2x minus 1. So I will start to type. You ready? Yeah. Y equals 2. And look at what happens. GeoGebra starts to graph y equals 2. That's not the equation I want, but that's what makes it a dynamic calculator. It starts to graph as soon as you start typing. So this is the beginning of changing the way you teach. This is the beginning of having kids be able to see what happens as you are creating this function, right? Y equals, let me put in y equals 2x. Boom, GeoGebra changes, right? That is the line y equals 2x. Still not the line I want, but again, the line is building as I'm going. Y equals 2x minus 1, enter, and there it is. There is the graph of the line y equals 2x minus 1. So dynamic, it builds and changes as you go. You can also go back, click up here and change any of the values anytime you want, right? There's no like going back and changing it and then watching like watching it redraw. You know what I mean? It just, boom, it just graphs.
Well, I like this because it shows you what every variable means, right? And you're showing it as you build, as you add, you see that change in the graph. And so it's not like the teacher saying, okay, graph y equals 2, and then they do it and they're like, okay, now erase that. I mean, you're seeing it happen in real time. And right. So the learning is happening in real time.
Yes.
I like that. That's very good.
That's the idea. That's why we call it dynamic. You know what I mean? It changes as you go. It's not like enter, having it where you have to hit enter and then watching the line form is like the old computer systems where it was like a batch job and you had to let it run it at the end of the day and hope at the end of the day you print out work type of thing. You know what I mean? That's like, and again, that's old news. Here I'll type in the equation x plus y equals 5. X plus y equals 5. Now you'll notice GeoGebra is doing that a little bit differently because it did not realize this was going to be a function when I started typing it because I started with x equals. But again, that's an advantage to an app type of calculator. You don't have to get everything in y equals form. Now, some teachers love that. Some teachers hate that. Some teachers love that their kids don't have to get the equation to be y equals every time because they don't want their kids losing points for doing the algebra when really it's a graphing problem that they're working on here. Some teachers don't like it because they feel like getting the equation in y equals form is an important skill. And I tell them, well, if that's the important skill, great. Then you tell your kid you'll only accept it if their equations are written in y equals form, right? So you can make this however powerful you want. And then here's, again, the biggest difference, Joe. You want to find the point of intersection. There's no button presses. There's no setting any kind of windows or anything. You want to find a point of intersection, just touch it. There it is. The intersection is 2, 3. You want to find a root, just touch it. There's where the root is to the equation, right? So you just touch things and you could find them. You want to zoom in and zoom out? Well, zoom in, zoom out. If you're on a tablet, right? You just pinch. Here, I'm going to zoom in and zoom out just by rolling my mouse, right? You could pull things around, put it wherever you want. And then, of course, again, setting windows and stuff, you want to get it reset to the center. Of course, a little icon for the house, right? The home button, boom, it snaps back to where you want it to be. Now, there's many other things you can do with the GeoGebra tools. In other words, line of best fit, right? This was my algebra tab. Here, if I go to my tools, I've got all kinds of different things that I can create. As a matter of fact, if I want to find that point of intersection, watch how easy it is with this tool. I go to my tools, I hit intersect. GeoGebra prompts me, intersection between what two objects? Well, this one and this one. And then GeoGebra finds point A. Let me go back to the algebra view. Here, you could see GeoGebra is finding point A. Point A is that the intersection of equation 1 and F, and it is at 2, 3. And again, what I tell people, Joe, is you might say, well, where are the coordinates on A? Why aren't they there? I said, well, they could be there if you wanted to be there. Remember, everything is customizable. Just go here to settings, right? Don't just show the object. You can also show the object's name and value. Close out of the settings, and there it is. Now you can see that A is at 2, 3. And because the algebra and the geometry together on the same screen, you can now manipulate those. In other words, you could take 3A and dilate it. There it is. 3A is at 6, 9. Where is it visually? There's point B at 6, 9, right? So everything happens here algebraically and graphically. That's just one calculator, Joe. Let's move on.
Yeah, that's fantastic.
Yep, let's move on. We found a point of intersection. Let me just show you how you can simply use a basic calculator to change the way you teach. You talked about variables. Let me type in y equals ax squared plus bx plus c. That's the general form for a quadratic equation, right? GeoGebra knows that x is the independent variable and y is the dependent variable, but it doesn't know what you wanted for a and b and c, so it turns them into sliders. Now, Joe, many teachers just tell their kids that this number at the end, c, that's the y-intercept. I don't do that. I never tell my kids that. I tell my kids to move c, change its value, put c down to -5, put c up to +5. What do you notice about the parabola as you change, c? And the kids will realize on their own, well, c is where it hits the y-axis. And I say, great, that means c is the y-intercept. And then I tell them, well, what about a? And again, many teachers will tell their students, well, that's the concavity. So it's concave up or concave down. I don't tell my kids that. I tell them, move a. What happens? So they slide it like this, and then they slide it like this. And the kids can realize on their own, if a is positive, the parabola is concave up. If it's negative, it's concave down. I always tell the true story. This is amazing. I had a student, when I was doing this lesson, once did that. And he said, Mr. P, I broke GeoGebra. I said, what do you mean you broke GeoGebra? Well, he said, look, it's not a parabola anymore. It's a line. I ran out of the room almost screaming with joy. I said, well, what do you mean it's a line? And the other kids started talking. Well, you made a 0. If a is 0, then the x squared term has got a 0 in front of it, which means x squared times 0 is 0, which means it's no longer an x squared term. It's not a quadratic. Now it's a linear. The highest exponent on the variable is 1. So now it operates exactly as a linear should. In other words, this is the y-intercept, and this becomes the slope, right? Yep. So what a teachable moment, right? What a teachable moment where a calculator can start to have the kids learn, explore, and discover.
Well, yeah, they are the one discovering it. Like you were saying, you don't have to tell the students this is the y-intercept. That you can say, what is the line doing? And they discover it's the y-intercept, and that sticks with them. When they discover it, it sticks. When you tell them, it's fleeting. Right. So I love this because that discovery is there.
Exactly. Yep. These are the different icons for the GeoGebra apps. Like I said, download them now on your phone. Put them on your cell phone. All completely free. Not 99 cents. Nothing. This chart gives a difference or variation in the app so you can see what's the difference between them. We're not going to spend a lot of time on them. All you need to know is that they have some very powerful apps. We'll look at one that could do calculus, differentiate, integrate, 3D apps, the whole works. Let me show you the 3D calculator, just so you can see it quickly. All right, let me slide this over. You can see this is GeoGebra's 3D calculator. Here is a 3D plane. You can see I can move it and look at this space in 3D. If I come here to the tools, I will quickly make a cube. And there it is. And I would ask my kids, well, how come I only had to touch 2 points to make a cube? And a student needs to understand that, well, because all the edge lengths on a cube are all equal, they're all the same length, right? So that if you know one edge length, you know all the edge lengths, there's your cube. And with just a touch of the button, I could turn that cube into a net. Some of the teachers that like the 3D calculator most, Joe, are either calculus teachers because they rotate solids around the axes.
Mm-hmm.
And the other teachers that like the 3D calculator most are junior high teachers because they have to teach surface area and volume. But let me remind you, this is GeoGebra, right? So let's go back to the algebra view. Here is everything that was used to create that cube. All right, I put 2 points down. I started at 0, 0, 0. I put another point B. It created a cube. And here is the slider that can open and close the cube. So as a matter of fact, I can even increase the speed of that slider. And there you can see the cube opening and closing in 3D. I could change the view of it. You know, when I first started teaching, I used to cut up like a shoebox to make surface area, right? And open up the sides of a shoebox, which was great. The problem is when I had to do a cylinder and I had to open up a tin can, I was cut myself with the tin snips. I had no leather gloves, right? So here you could do it all just visually. That's the GeoGebra 3D calculator. Another quick version, or another, I should say, image of another calculator. Here's the GeoGebra CAS calculator. I have a lot of teachers that use this calculator to make their own answer keys. In other words, so you could factor, and I'm not silly. I'm going to use something I know how to factor easily. So I'll put factor. GeoGebra will prompt me. I'll factor a polynomial. Let's factor x squared minus 25 because I know how to factor that one. Enter. There it is. It's factored as x squared minus 5 and x squared plus 5. And again, here's the visual of those roots, right? If that was set equal to 0, that's where the roots of that quadratic would be. So that's the CAS calculator. So GeoGebra consists of 3 things, really beautiful calculators. We just looked at 3 of them quick. Graphing, 3D, CAS. GeoGebra also consists, there they are, some really nice calculators. GeoGebra also consists of over 1 million free resources. Here, how do you get them? You just go to GeoGebra's website and you type in the search bar. Let me go back to the web, go to GeoGebra's page, and I start typing anything. You can see here's things I type. Exterior angle of a triangle. You just search for it. Up pops hundreds of resources just on exterior angle of a triangle alone. Now, Joe, there's good news and there's bad news to over 1 million resources. None of these are created by GeoGebra. They are all created by the user community. So when you have 1 million of them, the good news is you got 1 million of them. The bad news is that they're not all great. You know, these are created by users and they put them out there for free, just like GeoGebra is. They put them out there to the public. So you have to learn to pick and choose the ones you want. A little inside scoop, the exciting news is GeoGebra will start creating their own resources, and hopefully they will be available to people in September for grades 4 through 8. So that's new, and nobody else really knows that outside. But GeoGebra is going to be really excited to get their own really professionally made resources out there, so that it fits a certain standard, and you know what you're going to get when you pull one up by GeoGebra. But I mean, look at how great these are. I mean, you just click and open one, and here, there is a rule called the exterior angle theorem, right? For geometry, this is 10th grade, that says the exterior angle of a triangle is equal to the sum of the 2 remote or non-adjacent interior angles. Well, I don't tell my kids that. I hand them this, and I say, look, play with this. Tell me what you learn, and the kid starts to do it, right? And they play, and they can see that those 2 angles on the inside add together to make that outside angle. By the way, I do have to give a shout out. This resource is made by Tim Brzezinski. He makes some beautiful, beautiful stuff on GeoGebra. So over 1 million free things like that. But what good are, so let's go back. So GeoGebra consists of a bunch of resources. We'll look at more in a minute. Some of them are even games. You know what? Before I show you how to share these, Joe, let me just show you what I mean by games. This is GeoGebra Mini Golf. Created by at the time he was 21 years old, Steve Silvestri. He made this for his student teaching. He was teaching transformational geometry. So he made a 9-hole mini golf course. And here, the goal is to get this ball in that hole. Joe, all this is the GeoGebra calculator. He just changed the way it looked. This is the calculator, right? So in order to get this ball in that hole, I could translate, rotate, or reflect. I'm going to choose to translate it. I'm going to have to slide that ball left 2, and up 6. Look how good this student teacher made this. He's now working in the school district. He's very successful. So we got translation of -2, 6. If I swing, hole in one. Now, this is a 9-hole mini golf course with 3 transformations per hole. 9 times 3, 27 different transformations. Hey, Joe, I don't know what you were like as a kid, but when I was a kid, if you gave me a worksheet with 27 transformation problems on it, there's no way. There's no way I would have done it.
That's not just then, that's now as well.
Right. All right, there you go. However, you let me play mini golf, I'll do some of it. I still can't even guarantee I would do 27. But you know what? I would do a lot more, right? So over 1 million free resources like that. Here we go. Nice calculators, over 1 million free resources. We need a way to share those resources with our kids. This is now where you and I will do it together. I will use GeoGebra Classroom to copy and send these resources to you. Let's go back. We'll use that exterior angle resource. Here's how I do that. Okay. And now, Joe, remember, we're not good. This is not a whole lesson. We're just showing people what's possible. I like this resource. I want to share it with you. I will come up here and hit assign. Now, you can assign it through Google Classroom, right? Which is really very cool. It's completely integrated with Google Classroom. Here. But you're not in my Google Class, so I'm going to share it through GeoGebra. All right. And I'm going to rename it. I'm going to call it Q, Exterior Angle Theorem. I will create this lesson, and what I get is a join code. Now, I can give you this join code, or I could just simply copy this and put that for you in our Google Classroom or in our Schoology or whatever, school system you use. I can also put it as a link on a PDF, on a document. I'm sending it to you to the chat, and I'm giving you that resource. When you get that resource, you'll be prompted to type in your name if you don't have a GeoGebra account. And this is why teachers want kids to have GeoGebra accounts, because they want to get the kids' real names. And if you look at my screen, there's yours, there's mine. I could see you join my class. There you are, right? And I could see that you joined my class. And Joe, I can also see that you haven't started using that activity yet because you are still gray. So I'm going to ask you to click on that activity and start to move it around and move the points, maybe move the slider, and look at my screen. Look at what happened. You became color. You've advanced. I could see you're working on one of the 3 parts of that problem. I can click in here and I can get a bigger view of what you are doing and what you are working on. I could see you're exploring the exterior angle. If I had multiple students, I can scroll through them here. And people say, well, how many can you fit in here? I've done webinars where I've had over 300 people in my class. So you can scroll through 300 of these. You can get, again, the thumbnail view. If you're doing a webinar like I am now, I would probably hide the names so you could see you became student 1. So if it's projected to others, it's anonymized, right? You want to keep everybody's work kind of private to them. And of course, as a teacher, Joe, if I want to drag back your attention, I could see you're not watching me. I will pause the activity. And now you are locked, right? So you can't do anything else.
That's right. I am locked on my screen right here. I cannot do a thing. I must listen to my teacher to figure out what
you must. And you know what? My teachers in my old school, they would use these as starters, as warm-ups, as do nows, right? Or they would use them as exit tickets. And once they pause it, the student can't change it. That night, the teacher could go home, look and see what all their kids did, get a view of all the different activity that happened in their class. So, really, Joe, we have 3 things. Really smooth, pretty calculators. Over 1 million resources that are there for you to share and use at any time. And a way to share those with your students, which, again, is called, GeoGebra Classroom, right?
Well, and Rob, I love all of this, right? And people who are watching right now are probably saying, well, that's a lot of information. I really wish we can get hands-on with this a little bit more. We were talking before this episode, and we said we should do a workshop. And so we decided we're going to be doing a GeoGebra workshop on December 15th. That's next Thursday, December 15th at 4 p.m. Pacific time. And I have to say Pacific because you're on the Eastern time, so you'll be doing it at 7, but we'll be doing it here at 4. And one of the reasons we wanted to do this, everyone, is because we know that the following week, following 2 weeks is going to be your winter break. and maybe you wanted to dive in a little bit to test some of this stuff out before diving in January, trying this in your classroom. So we wanted to give you a nice workshop, hands-on, so Rob can give you some sample lessons and a little bit more instruction on how to implement this in the classroom. And so, Rob, we appreciate that you're available for that workshop. And everybody, all you have to do is go to q.org and then look under events, and it will be there. You can sign up there. Or if you are in the Q portal, just click on events in the Q portal, and it will be there as well. So we'll get that all set up this week, Rob. Yep. But until then, I really think that this can really, the visualization of the mathematical formulas is key to understanding these concepts. Otherwise, it's just letters and numbers to students. But when they see that what those numbers represent are actual physical items, graphs, surface area, these concepts become clearer. And that visualization needs to happen, right?
It's GeoGebra. It's the geometry and the algebra together. They're not two separate subjects, right? It's just different visualizations of the same thing. You talked about our session next week, Joe. I'm really looking forward to that. It's going to be fun. I want users to realize this, though. I showed a slide. GeoGebra's got all kinds of tutorials and videos that they could use to learn GeoGebra. Nobody really taught me GeoGebra. I was exposed to it by some people, and then I went and learned it on my own because it really is a modern, sleek, intuitive way to use a calculator and to teach mathematics. I invite all of your users to join the GeoGebra community. If they scan that code, basically they can get our newsletter and stuff like that. So be happy to have them there. Also, they can always reach out to GeoGebra at support@geogebra.org. And Joe, I do this every time. I throw this out to people. Anybody who wants a copy of my slides just to see some of the things, like, someone's saying, I want that mini golf. How do I get that mini golf that Steve Silvestri created? Scan this, put in your email, you'll get a link to my slides, and you can have those. But really, just go to the GeoGebra homepage, search in golf, boom, geometry, and there it comes.
Love it. Love it. And I love that these resources are the ease of finding these resources in the GeoGebra website is as simple as clicking and typing, right? And they're there. And again, just like you said, Rob, there's tutorials there if they want to get their toes wet now. But the workshop that we will be having next week is a place that you can get really some more hands-on training. Yeah. But dive into the GeoGebra website and look at those resources, play around, and then come for more fun on December 15th at 4 o'clock. So, Rob, I want to say thank you so much for presenting this. When we're done here, I'm going to go off and play a little bit more with GeoGebra because I want to see if I can do good on that mini golf game as well, just because I thought it was super fun. But everybody, go check out GeoGebra. Go check out the opportunities that you can be bringing into your classroom with this visualized learning of the mathematical formulas and how you can bring geometry and algebra together in a single platform called GeoGebra. Rob, thank you, my friend. I appreciate you being here. Thank you, listeners. Thank you for joining us for another fantastic episode of SuperShares. Until next time, have yourselves a wonderful, wonderful day.